Welcome to this presentation on ice cover, or as we describe it as freeze smothering. Here we are primarily looking at the injury a continuous ice cover can cause to turf grasses, primarily cool season turf grasses. We have previously mentioned the role of ice or water freezing with regard to freeze injury, specifically in freeze-thaw cycles. We will touch on that again later, but the focus here is on continuous ice cover. The major cool season turf grasses vary in their tolerance to freeze smothering. Dr. James Beard, while at Michigan State University in the mid-1960s, conducted controlled laboratory studies and field studies looking at the impact of continuous ice cover on the survival of 3 cool season turf grasses. He found that creeping bentgrass can survive for greater than 120 days under continuous ice cover, while annual bluegrass survival rate was half that time. Further studies from Canada found that the cold hardiness of annual bluegrass was lost within 30 days under an ice cover. Regarding annual bluegrass, it appears that 45 days of continuous ice cover is the threshold where ice should be removed. In these studies, the turf was encased in ice. This golf course is located in Chicago, and this screen shows the difference in freeze smothering between annual bluegrass and creeping bentgrass. Ice cover had exceeded 60 straight days on this screen, and the healthy strip of turf is creeping bentgrass, and the dead turf is annual bluegrass. The creeping bentgrass had been sodded a few years prior into this screen. So from a management perspective, a continual ice cover is not an issue with creeping bentgrass or Kentucky bluegrass, but freeze smothering can be a real issue with annual bluegrass. This screen is in the Detroit, Michigan area and was covered and encased in ice for a prolonged period of time. Based on how long a turf grass can survive freeze smothering, you probably can surmise that this screen was annual bluegrass. The most severe damage occurs with ice encasement. In other words, a thin ice cover that is located on top of the turf is generally of minor concern. It is when the ice has encased the turf that concern rises. Reasons given for why turf may die under a continuous ice cover is due to the buildup of toxic gases and/or development of anoxic conditions, resulting in a loss of cold hardiness. In herbaceous plants, the buildup of carbon dioxide under ice is a major contributor in plant death. Intermittent thawing or breaking of the ice cover helps eliminate gas buildup and provide oxygen to the plant, allowing it to escape injury. In this photograph, where the ice was cracked, the strips of turf are healthier than the turf under the ice cover. The escape of gases, primarily carbon dioxide, may explain the difference. The turf is annual bluegrass. The freeze smothering risk is primarily limited to annual bluegrass in northern and northeastern areas of the United States. For example, Michigan, and more specifically Detroit, often see freeze smothering and freeze injury. While we have talked about a continuous ice cover, ice formation and injury is associated with freeze injury that occurs in late winter or early spring. Freeze-thaw cycles that produce conditions where the ice melts then refreezes produces conditions that are ideal to cause freeze injury. This photograph may seem familiar since we saw it in the freeze injury presentation. The prior slide was the precursor to this slide, which was not in that presentation. From a management perspective, to reduce the likelihood of ice injury from smothering or freeze injury, maintain a healthy plant going into the winter. A healthy plant is more resistant to winter injury. In addition, install drainage systems that will eliminate the potential for water accumulating around the plant. Poorly drained sites can accumulate ice to a greater extent than well-drained areas. And when necessary, especially on annual bluegrass greens, physical removal of the ice may be needed. I've seen crews with shovels and picks trying to remove ice from greens. Here they are using a core cultivator to try to break up the ice and remove it. Snow removal equipment have been used to try to scrape the ice off. If you were to do this, just one practical point, make sure the green is frozen, because if it is not, you could drop this truck into the green. This concludes this presentation on freeze smothering.